Okay, so today the conic section we start is the parabola, and you guys are all saying, but we've already done parabola, and this is what we know, and x equals positive y squared is an up, opens up, and an x equals negative x squared is a down, and parabola that opens down. We're now going to talk about a parabola in standard form, which would be x minus h squared equals 4p y minus k, and y minus k squared equals 4p times x minus h, where hk are the vertex. Hk are the vertices. So notice we are going to have an x squared over here. Do not forget that that means it opens up or down, because we are now going to introduce a y squared, which means that we are going to open left or right. So we're going to have a left and a right. And I switched styluses. It's a little more exact, maybe. I'm having a hard time getting used to it, and I know it sounds, you hear it every time I click the screen, so I'm not so sure I like it. The other thing I just want to point out are in these beautiful looking things that will make you hungry, this would be example of a parabola. Okay, picture this cone on an upside down cone, and this will not ever cross the other cone, so this would give me a parabola. This will give me a parabola right here. Okay? And did you even know that SpongeBob used to talk about parabolas? Okay, by definition, a parabola is the set of all points equidistant from a point inside the parabola called a focus and a line outside the parabola called a directrix. Okay, so we're going to look at this quadratic, which you guys could easily graph. It has a vertex at 0, 0. The axis of symmetry is x equals 0. We could plot points and get it, but we're actually going to put it now in standard form. So that's going to be, x minus h squared, since it's an x squared, equals 4p y minus k. So I have to get the x squared by itself, okay? So this is x squared equals, and I'm going to multiply both sides by 12. Multiply this by 12 and this by 12. That cancels, and I'm left with x squared equals 12y. So obviously this is x minus 0 squared equals 12y minus 0. And I'm going to change 12 for graphing purposes to 4p, because I will need to know what p is. This is 4 times 3 y minus 0. So I now know that the vertex is 0, 0. And I know that p is called, p is the distance from the vertex to the focus. So what I'm going to do is I'm going to put the vertex on, and then I know this is an x squared, and it's positive. Okay, this is a positive 4, and so actually it's a positive 3, because the 4 is always positive, so I'm looking at the 3, it's positive, so it opens up. So my directrix is 3 units That's my focus. This is my vertex. It is also the distance, didn't want that in red, from the vertex to the directrix. So the directrix is also going to be 3 units away, and remember the directrix is actually a line. So the equation of the directrix is x equals -3. So with only these points, how do I graph my quadratic? Well, the last thing you need to know is the coefficient of y, which is the whole 12. The coefficient of y is actually the length of what is called the lattice rectum. And it gets measured from the focus, the length. So if the length is 12 from the focus, I'm going to go 6 this way to the right, and I'm going to go 6 to the left. This distance from here to here is 12, and those are the points that I would use to create my parabola. So let's look at one of these new guys that's a y squared. So y squared, we're going to get y squared by itself. So I'm going to multiply both sides by a -8. And I'm going to get y squared equals -8x. And again, I could put it into y minus 0 squared equals, I'm going to change this to 4 times p, which is -2, times x minus 0. So I know my vertex is 0, 0. What I now need to ask myself is I need to look at the original. Well, it doesn't matter which one I look at. I'm going to actually look at the 4p. So we're going to look at this, and I see not only is it a y squared, which means it's left or right, but it's a negative y squared. And yes, you've got it. A negative y squared opens to the left. A positive p would have me open to the right. So I'm going to plot my vertex, and I'm going to plot my p. P is -2. So instead of going forward for my focus, I'm actually going to go backwards, so negative. So my p is going to go, here. So my focus has a -2, 0 ordered pair, which means my directrix has to be a vertical line at x equals +2. Now, I know that the coefficient in front of y is -8, so the lattice rectum obviously can't be -8, it is 8. So from my focus, I'm going to go 4 in each direction, and then I'm going to graph my parabola. So this distance from here to here is 8 units. That's how I get my other 2 points. Okay, so real quick, let's just get a summary. If this is an x squared quadratic, it's going to open up or down. If it's a y squared, it's going to open left or right. if 4p is positive, so if p is positive, then I'm going to open up or right based on x squared or y squared. If p is negative, so really the 4 is always going to be positive, so if p is negative, then I'm going to open down or left. Okay, we know what the definition of p is. It's the distance from the vertex. Whoops, trying to do this too quickly. And last but not least, if I have a quadratic that opens up or down, the directrix will be a y equals directrix. And if I have, sorry, wrote that in the wrong place. If I have a directrix that opens up or down, then my directrix is going to have the equation y equals something. If I have a directrix that opens left or right, then my directrix is going to be x equals something. I don't really want to take too much time on this, but I was in Atlanta for the weekend and went to visit Taylor at Emory, and I just wanted to show you a couple cool things that I like. You can look up more information if you like, but the first one is just this Dooley character down here. You can see the little skeleton guy. Let me see if I can get it better. You can see the little skeleton guy in there, and there he is, the size of a building. This is Dooley Week at Emory, and Dooley has a really interesting historical legend which dates back to the early 1900s. The really cool thing I want you to see is this up here is a main road through campus. Okay, and this is a bridge, and there's a river that goes under there. That down there is one of their eating places that has everything from vegetarian to vegan to normal. They just offer everything. But here's what I want you to notice for all of you that are considering pre-med. So main drag, there's school buildings over here and there's school buildings down here. This right here is the entrance to the Emory Hospital. This is not the University Hospital, this is the Emory Hospital in Atlanta. And it has an opening onto the Emory campus, right off of campus. This is the Gonzaga business building back here. So what I learned was if you are in the nursing program, you are a nurse at that hospital your junior and senior year. You're actually in rooms with patients, in scrubs, etc. And obviously, a lot of the science buildings are on a building that is on the other side. You just come through here, you cut through the hospital, and your science classes are in a building on the other side. Very, very cool setup for anybody who wants to be medical. So here's a parabola in standard form. And before you can graph it, you really have to look at the function that you have and figure out, does it open up, does it open down, does it open right, or does it open left? So the first thing I look at is which is the squared term. And in here, x is the squared term. So because I have this and this is an x squared. So I'm either going to open up or I'm going to open down. The next thing I do is change this 8, which is the length of the latus rectum, to 4 times 2. 4 times p. So p is 2. And since 2 is positive, I know that I must be in an open up situation. So now that I know I'm in open up, I can write down my vertex. It's positive 3, negative 2. I don't know why I keep doing that. And I'm going to go to the focus. I know that p is 2. So I know my focus is 2 above this, and I did it again, didn't I? My focus is 2 above this, and my directrix is 2 below it. So my directrix is going to be here. My directrix would be y equals negative 4. My focus is 0.30. Okay, now I'm going to do the latus rectum, which we said was 8. So I'm going to go 4 units to the right and 4 units to the left. And I'm going to connect that into my parabola. Okay, the last thing they want are the intercepts that are parallel to the axis of symmetry. Well, let's do the axis of symmetry. I know is x equals 3. And so the intercepts parallel to the axis of symmetry are this intercept right here. That intercept is parallel to the axis of symmetry where my x-intercepts are perpendicular. So my y-intercept is where x equals 0, so I'm going to plug that in. 0 minus 3 squared equals, I'm going to distribute 8y plus 16. This is 9 equals 8y plus 16. I'm going to subtract 16. And then I'm going to divide by 8, so my y-intercept is going to be 0, negative 7/8. And then I'm going to visualize it, and that looks about right. And then my intercepts perpendicular to the axis of symmetry are going to be my x-intercepts, which are easy. That is negative 1, 0, and 3, 4, 5, 6, 7, 0. So now we're going to write the equation of a parabola with a vertex of 3, 2, and a directrix x 0. So the first thing I need to find is does it open up, down, left, or right? So I'm just going to visualize it. And if my vertex is here and my directrix is x equals 0, which is here, the only way this can open is to the right. It can't open to the left. It can't open up. It can't open down because I'm going to run into the directrix, and we know that doesn't happen. So this has to be a positive y. So I'm just going to write the standard form, y minus k squared equals 4p x minus h. And I'm going to insert my vertex. So it's y minus 2, careful, 4p x minus 3. So from my vertex 3, 2 to my directrix is this distance right here, correct? That distance right there. So from my x, which is 3, to my x equals 0, this distance would be 3. So that means that p is 3. So because my focus is going to be positive 3 on this side. So my final answer would be y minus 2 squared equals 4 times 3, x minus 3. So y minus 2 squared equals 12 times x minus 3. Okay, three more slides. You can handle it. So again, I need to know is open up, down, left, or right. This is a left. So this means my p, since it opens left, it means p has to be negative. So I have a vertex, and this is a y. So again, y minus k squared equals 4p x minus h. My vertex is 0, 0, which is kind of nice. Y minus 0 squared equals 4p x minus 0. And this is my p, right? The distance from the vertex to the focus. But I'm going left, so that's going to be a negative 1 distance. So p equals negative 1. So I have y squared equals 4p times x. So y squared equals negative 4x. All right, let's try one with ugly numbers. So I have a vertex of 8, 9, and a directrix. So the first thing I need to know is 8, 9 is going to be over here. My directrix is 73 over 8, which is about 9.125. So if this is 8, 9, then my directrix is a little above it. So that means this has to open down. So I know it's an x squared, so x minus 9 squared equals 4p y minus 8. And now I have to find p, and p is the distance from my vertex to my directrix. So if this is 9, this distance is 0.125, which is 1/8. So now we have to decide, is it x minus 9 squared equals 4 times positive 1/8 or negative 1/8? Well, since my focus is going to be down here 1/8, it would have to be a negative 1/8. So my final equation would be x minus 9 squared equals negative 1/2 y minus 8. Okay, so what does complete the square look like for a parabola? Well, again, I need to get the y's on the same side and the x's on the same side, but the question is, where does the constant go? Where does this constant go? Well, the constant goes on the side without the square. So I'm going to bring the x and the constant over to the left. So, and I'm going to bring this y over to the right with the y squared. So I end up with x minus 19 equals y squared plus 8y. And I'm going to put a blank because I'm going to complete the square here. I'm going to take 8 divided by 2, and I get 4, and I'm going to square it, and I get 16. So I'm adding 16 here, but I'm also adding 16 here. So on the left, I have x minus 3 equals, and on the right, this is going to be a binomial squared. Remember, this number, positive 4, gets dumped in here. So this is going to be y plus 4. I'm going to put it in the correct order. So I get y plus 4 squared equals 4x minus 3, because there is no p. I don't have p.